BCA-101, Introduction to Computers and Information Systems, Day 15, Monday, and today, 2/20, 17. Yeah, that's it. Start the next unit, details. Hardware, we talked about a lot of details in hardware. We spent the last 15 minutes on spreadsheets, and there was a block of 15 minutes in the middle where we listened to Dan Pink and the drive. So if you happen to be gone and you're going through this, you can do that on your own. I made note to the students, make sure they log off their accounts and turn off the monitors and leave the machine on. All right. System unit. So we talked about PCs, and they could be workstations, desktops, and laptops. Now there are some books, they call them, there's a term notebook, and there's some other types of devices, the mobile devices, but today we're just talking about these two, and we talked about, are the sales going up or down on PCs? Well, currently going down. I've read some where they say it's going to go up in a couple years, but I don't know. That might be wishful thinking for companies like Dell and Hewlett-Packard. What are you going to use the computer for? When you're buying a PC, it's like when you're buying a car or you're buying a house or buying whatever, unless you have unlimited funds and you like to spend a lot on stuff, you got to be concerned what you're going to use it for, so that you don't overspend or buy something and you don't ever use the capabilities of it. So here's what we talked about today. Motherboard, we actually looked at an example, and a lot of them are, there's two basic shapes or sizes, and then on there's a place to have memory and different types of memory on that motherboard, and slots to add memory and so forth. Random access memory, usually those are some kind of memory slots. We can add memory. Cache nowadays basically built into the processor. High speed area where it saves things it's working on most recently. Read-only memory, that's when the system boots. We have some memory, some software when the system boots. Basic stuff. And then there's also this option nowadays of flash memory. That can actually be used as storage, used in devices, and so forth. Really innovative type of memory. Okay. We talked about the processor, and these are Intel and i5 or i6 quad-core processors. There's only a couple things we're really concerned about here. In the processors, there are registers, high-speed staging areas to store the bits. And then once we bring the bits into a register, we can either do arithmetic, make a logical decision, or move that information around. So it's an arithmetic logic unit. And those are the two main things in the processor. So I think I talked a little bit about an example. You might have, you have in memory, you have your software, which has your instructions, and they leave there and go to the processor and get processed, stored in the registers, and then the processor sends the results back. How the information moves between these two, we use an electronic bus. It's built right into that motherboard. That was a little messy, but it's in there. Don't worry anymore about those details. Now, to offload some of the processing, we can add, your computers have graphics cards, or sometimes referred to as a video card. It can be a separate card in the device that has a processor on there that does some of the work, to send the graphics to the video, to the screen, the display. Okay? We'll talk a little bit more and look at one of those on Wednesday. The graphics abilities can be built into the motherboard or can be a separate card. Clock speed. Nowadays it's measured in gigahertz. Hertz, cycles per second. How many times it clicks per second, if you want to think about that. So you might have a computer that's a 2.0 gigahertz, 2.0 gigahertz processor, and then it actually takes care of the clocking in the machine. It would, as an example, it has, this is billion, so this would be 2 billion cycles every second. 2 billion cycles every second. And it takes so many cycles to move information from memory to the processor and from the processor back to memory. Now, when we run out of memory in, or I should say on the motherboard, they have this concept of virtual memory. They have a place they can put on the hard drive that acts like memory. And so if this is being taxied as far as how much is in there, you know, we're filling up, we can leave some instructions out here. Now, hard drives, you know, they operate at like milliseconds. So to get the information from here to use into the computer is pretty slow compared to nanoseconds inside the computer. You know, like a jet airplane and just like a tortoise. Let me try that. So if your memory is filling up because you've got all these different programs loaded, okay, or you got a huge file like a video file you're editing, the computer will start leaving some instructions in virtual memory. It's not real memory, but it's virtual. And then when it needs them, it'll swap them out. It'll take one from here and bring some instructions up and move some instructions out. On Linux, this is called a swap file. I don't think I mentioned that in class. On Windows, it's called a page file. And that comes from way back in time where they used to program in, you know, all the instructions in a page, and they could leave a page out here and have a page up here in memory. The one thing, you really don't want to be using that very much because it, like I said, milliseconds to nanoseconds up here. So when it comes down to performance in a computer, you could save money with an i5. Don't buy quite as fast a computer and spend all the money you can on memory. And you'll probably have better performance. But depending on what you're going to use it for. Right? The use of the computer. So if I was going to draw a picture, here's the motherboard. Somewhere's on there there's a processor. It literally is a little square. Somewhere's on there there would be these slots that would be for RAM, random access memory. There'd be a hard drive connected to the electronic bus in which your RAM is connected, and so is your processor. And so when you load programs, you know, it would load in here, and those instructions then go through the bus up here, sends the results back here. And then if you save your program, or save your results, then that's kept out here on the hard drive. So performance is really dependent upon the processor, how much memory you have, and gigahertz. All right, that's it for today.